All right, class, it's time for us to move to section 4.6 today. We're still multiplying, but this time we're going to multiply polynomials. Now, I kind of put a math problem up here, a blast from the past, when we were back in elementary school and we were learning how to multiply. If I had the problem 38 times 46, I could break that up into the tens and the ones. If you notice, I took 38 and made it 30 plus 8. I took 46 and made it 40 plus 6. And now I'm going to multiply the tens place. So 40 times 30 is 1,200, and then 40 times 8 is 432. And now I'm going to go back and multiply everything by the ones place. So 6 times 30 is 180, and 6 times 8 is 48. And did you notice I put the thousands in the same column, the hundreds in the same columns, the tens, and then we added them all up, and we got 1,748. Now, that's kind of a way to think about how I can take something and divide it up and look into two different terms and how to multiply. Now let's see how that equates, or what we need to see how that looks like if I'm working with my algebra problems and I've got letters and numbers. So if you look here at the first one, we're going to multiply a binomial times a binomial. We have 2n plus 7 times n plus 5. So if you notice, if I'm going to use the vertical format, that's what we're looking at right now, then I'm going to write 1, the first term, the first binomial, the second binomial right underneath it. And then we're just going to multiply. Now we're going to first multiply by n. So let's see what that looks like. We've got n times 2n, n times 2n, which gives me 2n squared. And now I'm going to go back and multiply n times 7, which is 7n. So you notice I'm taking the binomial on the bottom and I'm multiplying each of individual term by the top. Now, we multiplied everything by n, so now we need to go back and multiply everything by 5. Okay, so here we go. 5 times 2n is 10n. Where do you think I should put that 10n? Yeah, that's right. I'm going to put it right underneath the 7n because I want like terms in the same column. And then we've got 5 times 7, which is 35. Okay, so now we just add up our partial products. Now, I really like the vertical method because my like terms are in the same column. So if you look here, 2n squared is by itself, so it doesn't have a like term. It comes down. Positive 7 and positive 10 gives me positive 17n, and then 35 just comes down. It doesn't have a like term. So we have 2n squared plus 17n plus 35. Now, there is another method, okay? And the next method, I'm going to get this out of the way so it doesn't distract us. The next method is called the distributive method, or distributive property. If you notice, I have the exact same two binomials, but I take that first binomial, if you look right here, and I divide it up into its two terms. It's 2n times the second binomial plus 7 times the second binomial. Well, then we've got distributive property times 2. We're used to doing that from chapters 2, and we take care of our distributive properties, and then we combine like terms. So if you remember, we got the exact same answer. I just used two different methods to get there. Now, personally, Mrs. Burton doesn't care which method you use. I just want you to take the method that works best for you and perfect it, and that's what I want you to use over and over again. So let's try using each method again to make sure we understand which one works better. So if I'm looking at number 1 here on my next slide, we're multiplying a binomial times a binomial, and I want us to use the vertical method. Okay, so I'm just going to go ahead and take 2k minus 3 and write it underneath. Here we go. We're going to multiply now. We're going to take the terms on the bottom and multiply by the terms on the top. So we've got 2k times 5k, which gives me 10k squared. And then we've got 2k times 2, which is positive 4k. Well, we multiplied everything by 2k, so now we need to go through and multiply everything by negative 3. So negative 3 times 5k is negative 15k. And remember, I'm going to put the k's right underneath each other. And then negative 3 times 2 is negative 6. And now I'm going to add them over here because I ran out of room. We've got 10k squared. We've got positive 4k and negative 15k, which gives me negative 11k minus 6. Okay, so that's the vertical method. If you like that method, that's what I want you to use tonight on all your homework. Now, let's try another one using the horizontal method. Remember, we're going to take the first binomial and break it up into its two terms, term number 1 and term number 2. So we've got 3x times the second binomial, 3x minus 7, and then we've got plus 7 times 3x minus 7. Did you notice I repeated that second binomial twice? Because we're breaking up the first one and multiplying by each of the parts. So let's multiply and see what happens here. We've got 3x times 3x, which is 9x squared. 3x times negative 7, negative 21x. Now we're going to go over to a distributive property number 2. We've got 7 times 3x, which is positive 21x. And then 7 times negative 7 is negative 49. Now remember, when you're doing it the horizontal method, you got to remember to collect like terms in the middle. But this time, my like terms cancel each other out. They're inverses of each other. So I'm left with 9x squared minus 49. So you got to decide, do I like vertical method like number 1, or do I like to do horizontal or distributive property like number 2? Well, what happens if I give you a binomial times a trinomial? Now the directions say multiply using the horizontal form and then arrange the terms in each factor in order of decreasing degree of one of the variables. So remember, we learned that if it's in standard form, my exponents descend or go down. So I'm going to take this binomial and bust it up into two parts. I'm going to say 2y times my trinomial. I'm going to write all that down. And then I've got minus 3 left of the first, and then we're going to multiply by 2y minus 4 plus y squared. Okay, so we've got distributive property times 2. So here we go. 2y times 2y is 4y squared. 2y times negative 4 is negative 8y. And then 2y times y cubed is going to be 2. I just told you the answer, 2y cubed, because it's 2y. Anyway. Now, let's multiply everything by negative 3 over here. So we've got negative 6y, negative 3 and positive, negative 4, negative 3 and negative 4 is positive 12, and then negative 3 times that. Now, remember, they want us to put it in descending order. So who's my highest degree if I look there? Yeah, my highest degree is y cubed. Well, is there a like term to go with 2y cubed? No, all by himself. So we're going to put him first because that's the highest degree. All right, so now after y cubed comes y squared. So we've got 4y squared. Who's going to combine a like term with 4y squared? Yeah, we're going to go over here and say negative 3y squared. 4 minus 3 is positive 1, or you could just say y squared. We've done y cubed, y squared, so now we need the y's. If you notice, I've got negative 8y and negative 6y. If I combine those, negative 8 and negative 6 is negative 14y. Who's my constant term standing all by himself? Okay, and then we just got plus 12 on the end. Nice. Okay, let's try the last one then. Let's go ahead and use the horizontal method because that's what it says to do. So we've got y times 2x squared plus y squared minus 3xy. And then we've got minus 2x times that trinomial again, x squared plus y squared minus 3xy. Okay, so we've got distributive property times 2. So here we go. Y, so we're going to have 2x squared y. Y times y squared gives me y cubed. And then when I multiply the last one by y, we've got negative 3xy squared. So we took care of distributive property number 1. Now let's look at distributive property number 2. This time we're multiplying by negative 2x. So the first one times 2x squared is going to give me what? Negative 4x cubed. Negative 2x times y squared gives me negative 2xy squared. And then negative 2 times negative 3 is positive 6. And then we're going to have x squared y. Now, notice we've got to be very careful and slow and intentional because we've got to worry about all these exponents. So now, let's go ahead and combine like terms. Well, let's see. If we're going to descend, let's go ahead and descend with x cubed because it comes first in the alphabet. So do I have another x cubed? Well, when I look there, he's all by himself. So we're going to say negative 4x cubed. Now we're going to go with x squared. So we've got 2x squared y and 6x squared y, which is going to give me 8x squared y. And now we've got x cubed, x squared. Now we need x by itself. So that's going to give me negative 3xy squared and negative 2xy squared, which gives me negative 5xy squared. And we've still got this y cubed on the end. Nice job. Now, we've got one more problem to look at. If you look at this one, it says solve. Uh-oh. Notice we got equal sign now? Solve. We've got to solve for x. Isolate the variable by inverse operations. But before I can solve anything, if I have a binomial written beside a binomial, what do I have to do? Yes, I have to multiply. Well, I'm going to use the vertical method because it's easier in the space I have. So I'm going to multiply 3x plus 5 times 2x minus 3, just like we did at the beginning of today's lesson. So 2x times 3x is 6x squared. 2x times 5 is 10x. Now we're going to go back and multiply everything by negative 3. So negative 3 times 3x is negative 9x. Remember, we're putting like terms in the same column. Negative 3 times 5 is negative 15. And then I combine my like terms. 6x squared, 10x, and negative 9x is 1x minus 15. There's going to be an equal sign in the middle. Now, let's go over here and do the same thing with my second pair of binomials. So I'm going to multiply the top by x minus 1. So we've got x times 6x is 6x squared. X times 5 is 5x. Now we're going to go through and multiply everybody by negative 1. Negative 1 times 6x is negative 6x. Negative 1 times 5 is negative 5. Let's add them up. We've got 6x squared minus x minus 5. Okay, so we took care of multiplying our polynomials. Now we need to solve for x. Now when I look there, oh my goodness, well, we got to get letters on one side, numbers on the other. So let's go ahead and let's subtract this 6x squared over here. Ooh, guess what happens? That works out pretty nice. Both of those cancel. So I'm left with x minus 15 equals negative x minus 5. Now that looks a lot like a problem we did back in chapter 3. So I've got to get letters in the front, numbers in the back. So I'm going to add x here. So I've got 2x minus 15 equals negative 5. That's right, my floater's 15, so we're going to add 15 to both sides. I'm running out of room. I'm going to go over here. So now I have 2x equals 10. And if I divide both sides by 2, x equals 5. Okay, now there is one of those on the quiz on Monday, so make sure you understand how to multiply our polynomials.